This is the Group 7 Senior Design Project Design Concept Presentation being presented by Robert Stoffel and Marcus Smith. We were tasked with building a robot that will play ping-tac-toe, and basically it requires the robot throwing the ball, bouncing it off a platform into some cups, and then the winner is whoever gets tic-tac-toe first. And here you see a top module of our robot. As we go through this presentation, this will get broken down into more specific areas of what we will actually be building. Here you see the concept we came up with. We will be using two motors to spin wheels that will launch the ball down towards the playing area and hopefully make it into some cups. We will also have a base that will rotate, and this will let us aim at all the different cups we will need to hit. Here is a close-up of our launching system. You can clearly see the two motors that will spin the wheels. And on the track that the ball will actually run down, you can see we have laid down some track that will keep the ball in place, and hopefully this will provide more accurate shots for us as it launches off the end of the robot. Here is a picture of the motors that we will be using. They are 6-volt super high-speed motors, and they spin at a maximum of 17,000 RPM, but that is more than we will be needing for the distance need to be covered by the balls. Here you see the next level in our functional decomposition of a robot, which consists of a mechanical structure, the ball shooting system, the power supply, and the control system. The mechanical structure is essentially just the robot that we built, just the structure of it, none of the items to power it or actually make it play the game. The ball shooting system is what we will be using to actually shoot the balls, meaning the spinning wheels. The power supply is an AC to DC converter that we'll be purchasing. And our control system is what we will be using to control our robot, meaning where we're aiming, the strategy using to play and win the game, and how fast our wheels are spinning.
Here you can see the position of the track and the relative position of the motors and wheels that will be guiding the ball down the track at different speeds. And this is what we're actually going to use to actually assemble our track. And here's the Lazy Susan that we're using, and we're going to try and use the servo motor to control the angle that the robot will be facing in order to hit the inside or the outside cups. Here you can see the actual structure of our system. We have the ping pong balls, how it's going to be loaded, the amplifiers, where they're going to be at, and the control system and vision system. And these systems are going to be shown much later and in more detail. As stated before, we're using the rotating base and a motor that will control that rotating base, as well as two motors to control the speed of the wheels. This gives you more detail on what that system does in each point of the components. Here's the physical structure of our thing, how a robot is going to be set up, as well as how it's going to release the balls. And we're going to be using the amplifier in order to amplify the signal that we're getting. And it's going to be used to power our motor. As stated before, we're going to be using motors to control the speed of the wheels and change them at different speeds. And depending on what voltage we're getting in, the controller will actually give the signal, the voltage signal, to these motors in order to get them to change speeds. And we're going to use our vision system in order to plan our strategy and what we want, what speeds we want these motors to be on, and how they're going to be used to angle the ball in order to hit our target. Here's the physical structure of our robot, what we have done already. As you can see, we've connected the towers and the Lazy Susan, and we've actually put the Lazy Susan onto the track. Like we did in Lab 2, we're using closed-loop control in order to control the motors in our system. As I stated before, we're using the amplifier, and we're going to have to determine the exact speed that we have to have these two wheels spinning at in order to hit our target. In order to control our robot, we're using XPC and MATLAB, and in order to control the direction and that we point our motor in, we're using a potentiometer connected to XPC. Here's the functional breakdown of our whole system. It's like you've seen before, except we have the Q4 board, XPC target, the camera, the laptop, feedback, and the motor in there as well. The feedback is going to help with the potentiometer, because the potentiometer uses that feedback signal in order to adjust the angle to the exact position that we want it at. And we're going to do this with the Q4 board in order to control their positions and what signals are going to. The laptop is going to be our host target that we're going to use and actually control what systems are working at XPC. And this is the system we're using to program our robot in. So we're going to use MATLAB and MATLAB code in order to program this robot. And the camera is one of our sensors that we're going to use, and we're going to take the code and the images we get from our camera and tell our robot what strategy we're going to use in order to hit what target we want the robot to hit.
And that is our presentation on our design concept, and we feel very good about this design. Feel like it's going to be a winner.